Hi guys, welcome to another Leetcode problem. Today we're solving house robber 2. So yeah, this is again the same way that we were doing questions. I'm reading the question for the first time and we'll try to think of an approach right now. Question is where a robber planning to rob a house along a street is a certain amount of money. All houses at this place are arranged in a circle. That means the first house with the last. Okay, we join with the last one. Adjacent house system have a security. It will automatically contact the two. Okay, so we can't rob two adjacent houses. Amount of money in this house. Return the maximum amount of money we can take without alerting the police. Okay, 232 is there. Let's take this example. Let's take an example with the odd number of houses. Okay, so let me delete this. Come on. Okay, and yeah, so text. This would be our house, and let's say second case would be uh, this. Let's say after one, I have five again. Okay, so in this case, I can start. So this is one, two, three, and then one is again. So these are like in a circle. In this case, one, okay, two, then there is three, then there is one, and we have five again. Okay, so if oh shit, that is fine. So if there is two choices, if I start at one, I can take one, I can't take two, I can take three, so that would be four. Come on, that would be four. Second option is I don't take one, then I can start at two, so I'll take two, I can't take three, I can take one, and I can't take this one also. So that is three. So this one would be our answer. In this case, if I take one, I can't take two, I can take three. I can't take, if I take three, then I can't take this one. Also, I can't take this five also. So this is also gone. So for one, these two can't be there. These two are possible. So among these two, I can take three. I can get four. But if I don't take this one, okay. So this one is possible. This one is possible. And so if I take two, if I take two, I can't take three. I can take one, and I can take five also because these are so okay. So if I don't take this one, five and two can come together. So that is seven. But if I skip this two also and take three instead, yeah, five and three, eight I would get. So that is the like best scenario. Okay, so this looks like a DP problem. For each house, we'll have a choice if I want to take this house or not. Of course, based on the condition, if I took the previous house or not. And for the last house, there would be two conditions. I'll be able to take this house if the first house was not taken, and if the previous house was also not taken. All right, and I need the maximum answer. So let me set this up. This n value of n is from 0 to 1000, so minimum answer is 0. Okay, let me initialize it here, and then we'll have a robber method. This will take nums, this will take the int I, which will start from 0. This will take prev, if previous house was taken or not. So for the first one, that is false, and what else, and current sum, which would be 0. And okay, also the condition that the first house was taken or not. Okay. Hmm. So is this the best way to do this? First house was taken or not. So for every house, I would have a choice if I want to take it or not. But I need the previous, if the previous one was taken or not. For the last house, I'll need to check if the first one was taken or not. Okay, I think a better way of doing this would be having a visited array. Visited as in taken. Let me call it taken. Um, So taken equals to new boolean size would be nums dot length. Okay, and so I'll be robbing this. I won't need this variable. So this would be private. I don't have to return anything. And then this is robber and array nums. And then I'll have what is this int I, and then we have boolean. Okay, this is also not needed. I can just simply check if previous one was taken or not, and this is sum. So let's call it money. Okay, first of all, if I greater than equals to nums dot length, so we don't have anything to process. The answer, okay, answer equals to max answer, comma, the money I have right now. Okay, and then we'll have to return. Otherwise, for every so the first scenario is so for, let's say, for every house we have two choices. I can rob the house or I can skip it. If I want to rob a house, there are certain conditions that need to be valid, that the previous one was not robbed, and if the current house is the last house, then the first house shouldn't have been robbed. So there are multiple conditions, but if I have to skip this house, then that is very easy, right? So let's try skipping this house first. So I'll say I won't rob this, so I can just go to the next house. My money would remain same and the visited array would also remain same. Second condition is, can I rob this house? So if I not equals to 0 and taken of I minus 1, and this is false. So taken is a boolean array. So I minus 1 was not taken. I is not equals to 0. I is not 0. So this is one condition. Let us simplify this. So firstly, if I 0, then the simple visited of I equals true. So it's not visited, sorry, taken. So I'll take the 0th, then I'll make the same call, but this time it would be money plus nums of I. Okay, I go next. I can only rob one house once only, so I can go here. If I take this house, minimum jump would be I plus 2. That would put me out of the array, but yeah, I don't think that hurts. I plus 1, I plus 2. I take this one. I don't go to the next one because I know the next one anyways cannot be taken, right? So, and let me reset this. Correct. Now, else if I is not 0 and I minus 1 is not taken. So in this condition also, I'm going to repeat the same thing. I know there is repetition of code. I could have put this in a single or with like or statement, but I want to keep the logic simple. All right. So if I is not 0, so we are in the middle of the array and I minus 1 was not taken, then I can take it, but there's also an additional condition. So if I not equals to nums dot length minus 1, so it is some middle element whose previous element who was not taken, then I can simply do this. But if I is nums dot length minus 1, okay, firstly let me else. So this says if I is not 0, so it is somewhere ahead in the array, and I minus 1 was not taken, so maybe I can take this one, but only if this is not the last element. This is not the last element, somewhere in the middle, previous one was not taken. I will take this and I'll reset this. But if it is the last element, so so else is if it's the last element, if and only if taken of 0 is false, I will take it, or taken of 0 is false. So if I is okay, let me combine these conditions. So what basically we're saying is, if it is not the last element somewhere in the middle, so we already know that it is previous one is not taken. Now if it is not the last element somewhere in the middle, then I can take it. Or this condition, or and not. So basically we're saying if I is not the last element, then I can take it, or I is the last element and the first one was not taken, then also I can take it. Correct. And this is how I will reach the last, and my answer would be updated, and here I can return the answer. Let's try this. Perfect. I am getting this. Yeah, and every time we are doing I plus 2, this is like a very minute optimization, because I know anyways the next sorry, the next element cannot be taken. So that, and eventually we reset, we have the maximum answer, and then we're returning that. All right. Okay, so we have a TLE for a large case. What are we missing? Okay, so this is our recursive solution, um, and we'll probably need to memorize it. Okay, fine. So this is the recursive solution which we know works. Now we need to start storing the intermediate values, correct? Now how I approach this is, I I like to memorize the recursive solution instead of doing the top bottom up, top down, whatever, because memorization is very intuitive. I just have to store the intermediate results. So what can we do here? What can be the intermediate, the temp answer? In this case, I is changing, and the the fact, okay, what is changing in this case is who was taken or not taken in the previous. Okay, so we need to identify factors that are changing and factors based on which we can save the intermediate answers. Okay, so firstly, for when we want to memorize it, we can't take this approach of reaching the end and saving the answer. From here, I'll have to return the answer somehow. For every step, here I will get the intermediate answer. I will save it in my DP, the memorization space, and then I will return that answer. Like, what can I get maximum from here? Okay. Okay, fine. So firstly, this is going to change to int. Mm, I still need to identify the factors based on which I'll save my intermediate answer. So when I have exceeded the length, I can just return money. I'll have a temp answer. I will have to maximize this answer, of course. So this temp answer is initialized with the when I don't take this guy. I don't think money would. Yeah, money won't be a factor now. So it is like what will be the next part of my array returned to me. So when the array has ended, answer would be 0. Temp answer is I will skip my current one. I'll just go to the next one. So that's why nothing is getting added here. Okay. Now if I is 0, so yeah, now I want to now I want to think about the factors. So finally from here, what I'll basically do is save temp answer and then return temp answer. Temp answer is basically trying to mhm. So maybe I have a second variable that tells me if I can take this particular mm, element or not. Okay, so for any element, any house, what that house can return depends on if the previous house was robbed or not. And if it is the last house, okay, so for any random house, the value that that house can give me depends on the fact that if the previous house was robbed or not. If the previous house was robbed, I only have option to skip this. If the previous house was not robbed, I can take this or I can skip this. So that's two options. Mm, okay. Okay. Mm, so if I is 0, basically I need this previous. Okay, I need a variable called previous. I need a variable called first. Okay, let's put those. Maybe they'll be useful for our okay boolean. They should be boolean first. They'll be useful in our DPR. Okay, let's remove this entire thing. So firstly, boolean can take if I is 0, pre and first both will be false. For any okay, if I equal 0, in that case can take equals to true. Else if I equal nums okay nums dot length -1. So this is the last element. If not pref and then not first, the first was also not taken, previous was also not taken, then can take equals to true. Let me set it to false. Can take is true. Else if not pref, so pref was not taken, again can take equals to true. If previous was not taken, then can take is true. Otherwise can take is false. Correct. Come on, now I'll have to convert this to okay. I'm gonna call it 1. Okay. So basically return dp of I comma can take equals to temp answer. This calculation will have to go here. So can take is 0. Now this calculation is there. We have can take. If this is not equals to -1, then I'll return this. Come on. Okay, otherwise I'll form a temp answer. Now temp answer if can take. So I have the option. Maybe I can get a better answer here. Temp answer. Okay, equals to dot max temp answer comma. Let's try robbing this house. So that would be nums of I plus robber. Send the nums. I let's skip it by 2 because I can't take the next one anyways. Previous. Okay, we'll have to. Previous was taken, so previous is true. First remains first. Mm, okay, if can take. So if I can take, if I'm taking the first one, 0, then first is also true. And then this is temp answer. I could have started here with and without first. That would have been simple. This was not taken, so false. And if it I is 0, then first is also false. Else, so this was not taken, so this is false. This is not I 0, so this would remain what it was. Okay, since when I'm not taking I 0, I'll send it as false. When I'm taking it, I'm sending it as true. Your temp answer is updated. Okay, this should work, but there is a lot of there are a lot of issues in this code. So this goes uh, false and false, and I'll have to return DP of hmm, so one thing for 0, 0 is like 0 we can take, right? We can't take something. For 0, can take is 1. Okay, how about you just return from here? DP will have to initialize. Hmm. So this condition is there. ENGTH. All right. Let's use this one to test once. Still getting TLE, or we have a wrong answer. Okay. What is causing that? So my can take variable depends on first and previous. Okay. Am I doing anything? I might not be doing anything wrong. Sorry, the screen recording got interrupted. Meanwhile, I was trying to figure out the problem. Um, so I changed the solution a bit. Now what I'm doing is I'm starting at index 1 straight up instead of 0, and I'm starting there with the two cases when I have not taken the first house and when I have taken the first house. So I include it, and then first is set to true, previous is also set to true. I'm getting the same problem with this solution also. I'm getting answer 4173. Actual answer is 4077. So same issue as the previous problem. So I kept thinking around this one. So I realized that when we are taking this, so when I can take this, I'm just going to the next one with the previous set to 1. I thought this is unnecessary, but I thought maybe we should do it because I'm anyway setting it to true. So I thought maybe I could try another approach. So this is the solution that I reached finally. So here what I'm doing, again I'm starting with index 1 only. uh, so yeah, if I don't take the 0th index house, I start at 1. If I take that house, I don't need to start at 1, I can start at 2 straight up. Correct. And this is the if first was taken or not. So two conditions. So I try to simplify the problem. So imagine for any house, what is the variable. If you look at so if I take any house and I skip the next one and I make a jump straight to I plus, so here if you see temp answer, if I'm taking a house, I am straight up making a jump of 2, so I'm skipping the house, I'm reaching the house that can be taken. So I have sort of taken out that extra variable that I had can take. I don't need it. Whenever I am at a house, I can take it, that's for sure. If I choose to take it or not, those are two different things. But whenever I am at a house, I can definitely take it. So imagine the scenario: you're hopping onto the houses that you can take. Correct. Now it's your choice if you want to take it or not. Correct. Now the problem would the changing variable would be if the first one was taken or not, because that would change your entire answer. So index and this first was taken or not are the two changing variables here, nothing else. I sort of overcomplicated the problem in the beginning. So what I'm doing now is I start at 0, I don't take the house, or I take the 0th house and I straight up go to 2 with first set to 1 means first was taken. The age condition is if I don't have anything left in the array, or if I am the last house and first was taken, then again I don't need to do anything, I can simply return. This is your DB condition. And then temp answer is for any house, whether I can take. So any house I can take it, that's for sure, whether I take it or not. So I don't take the house, so I go to the next one, first term is the same. Or I take this house, I make a jump of 2 now, and first term is the same. First is only helping in the DP, and this is it. So this was working. Yeah, I sort of complicated the problem by taking that can take variable and everything. uh, so this should work perfect. All right, cool. I think I should I'll do house robber, the first problem again, and then we can move on to house robber 3 and 4 also. All right, thank you. Bye bye.